Welcome to another episode from Spiral Physics Education. In this episode we're going to be looking at measuring acceleration using light gates. And what will be really helpful for you to know in this lesson to get the most out of it is first of all how to use light gates to measure velocity. Also how to calculate velocity, how to calculate acceleration, and know that light gates work together with data loggers to measure time. And if you're not sure about how to do any of those, check out some of the other videos on the channel and they'll help you get up to speed, so to speak, with those issues. So let's do a little bit of a reminder about light gates. And light gates are used a great deal in physics practicals, so it's very important to understand what they're used for and how they work. So this is an example of a light gate that you might have seen in the physics laboratory. But what might not be clear is that there's actually an invisible beam of light that passes between the gap, and that's in the infrared spectrum. And what happens is when an object breaks that beam of light, the data logger just records the time that it's broken. And then it can use one light gate, two light gates, and be programmed to calculate velocity and acceleration if more information is provided. But the good thing about light gates is that there's no humans involved, and that means that there's no reaction times. So they're going to be more precise, and therefore they're going to be more accurate. So let's have a look at a method of using light gates to calculate acceleration. So in this one we're going to use one light gate, and we're going to use a data logger as well. And we're going to use an interrupter card, which we use when we're calculating speed. And the interrupter card is just used to break that invisible beam of light by the light gate. And what we're going to do is we're going to use the information from that interrupter card and the light gate to calculate the final velocity of this trolley at the bottom of the ramp. So when the trolley passes down the ramp, the interrupter card breaks the beam of light, and it's going to time how long that interrupter card has broken that beam of light. But to help out, we need to measure the length of the interrupter card, and we need to input that into the data logger. So the data logger is going to record the time, and we're going to tell it the length. And then it's able to do this calculation. It's able to record the instantaneous velocity right at the bottom of the ramp by using the card length that we've told it divided by the time that it's measured. So what we're going to do is we're going to release this trolley from rest, which helps us out a little bit because that means that the initial velocity of the trolley is going to be 0. And we've calculated or measured the distance that the trolley is going to travel. And we've also calculated the final velocity that the data logger has used. But remember, when you're measuring length, or if you're answering a question, make sure that you say you're measuring the length that the trolley moves by using a ruler. It's important to say the physical quantity with the device that you're using to measure it. And what we're going to do with all that information, we're going to use this equation. And if you're unsure about that equation, do check out some of the other videos on the channel, because there is one on equations of motion that shows how to use this equation. And because we're going to be calculating acceleration, we're going to rearrange it into this format. And I would advise you to do some practice if you're not very confident at rearranging equations, especially one that's a little bit complicated like that. So we do a little example for you. Here we've got our trolley. It's going to travel 0.85 meters down the ramp, which has been measured by using a ruler. And it's held at rest, so that means that the initial velocity is 0. And there it goes. It breaks that beam of light. And the data logger calculates that the velocity at the bottom is 1.3 meters per second. But don't forget, we've measured the length of the interrupter card, and we've placed that data into the data logger so that it can calculate that velocity. So the acceleration can then be calculated and we're going to use this equation. We're going to turn it into this version of it so that we can calculate acceleration, substitute in the values, and then we get 0.99, but that's not the end of the answer because we need to look at the units. We're dealing with acceleration, so that's meters per second squared, and we're just quoting that to two significant figures because that's appropriate for this question. So let's have another look, or a look at another example. This time I'm going to use two different light gates attached to a data logger, but we've still got an interrupter card. And once again, the length of the interrupter card is measured by the student, and that information is input into the data logger. And then what happens is when the trolley breaks, or the data logger, when the interrupter card breaks the light gate, the first light gate, then it's going to measure the time that that interrupter card breaks that beam of light, and it can calculate the initial velocity u, and it can do that by using this equation. The initial velocity at that first light gate is the length of the card divided by the time that that interrupter card breaks that beam of light. So the trolley with the card then attached is then going to break the light in the second light gate, and when it does that, it's going to record the amount of time that that trolley or the interrupter card breaks that beam of light, and it's able then to calculate a second velocity, if you like, the final velocity. And it's going to use the same equation. Obviously the values will be slightly different if it's accelerating, but the final velocity at that second light gate will be the length of the card divided by the time that that interrupter card spends in that beam of light at that second light gate. And what the data logger also does, the data logger also records the time between the two light gates. And what that means is we've got time recorded, we've also got the final velocity recorded, and we've also got the initial velocity recorded, and all of that is held within the data logger. And the user doesn't need to do any calculations, but what the data logger does, it calculates the acceleration using that equation. And because the only thing that the user has measured is the length of the card, that actually is a very accurate way of calculating the acceleration of the trolley. It's not perfectly accurate because you may not measure the length of the card properly, or the trolley might actually not quite travel straight through the beams of light. So there are other uncertainties involved, but it's a better method than using just one light gate, or using a stopwatch, for example. So let's go look at a third method of using light gate to calculate acceleration. And this one's quite common method, is that the shape of the interrupter card changes a little bit. And it's going to be a U-shaped interrupter card. And those two U-shapes, or the two bits that are pointing up, those two sections break the beam of light. But it's very similar to the last one, but we've only got one light gate. So the light gate, the data logger is going to be programmed with the lengths of those two sections. So it knows the length of the first section, it's going to know the length of the second section, and what it can do then, it can measure the time that it takes the trolley to pass by in those two sections. So the first section of that U-shaped interrupter card breaks the beam of light, and it calculates the initial velocity using this equation. There he goes. And then the second section breaks the beam of light, and that means that the data logger can calculate the final velocity using this equation. It's not quite done there. We still haven't calculated the acceleration, but it records the time that it takes for those two different sections to pass the light gate, and then it can, along with the initial velocity and the final velocity that it's calculated, it can use this equation, and it can calculate the acceleration that way. And there's one final method that you may have come across, and that's using something called a picket fence. And a picket fence is a piece of plastic with opaque and transparent sections on it repeated several times. So it looks a little bit like a picket fence. And we're using one light gate and a data logger here. And it's very similar to the U-shaped method, but you consider that the picket fence is made up of several pairs of views. So what will happen is that the first opaque section breaks the beam of light, and then a second section breaks the beam of light, and you've got two velocities that it will calculate the acceleration to, and then it will pair up another pair to sections that are opaque, and another pair, and then another pair. So what it ends up doing, doing several acceleration calculations because there are lots of different breaks in that interrupter card. But it's still using that equation, so it will do that several times for one run of the trolley. And this method is more reliable than all the other methods because you get several values of the acceleration in one go, and that means that you can spot anomalies and discount them, and that you can calculate an average, and therefore you're producing data that is very reliable compared to the others. And it's really important that you're aware of all of these different methods of calculating acceleration using data loggers and light gates. Do check out the channel for other ways in which hopefully can help improve your physics and your grades. And I'll see you next time on Spiral Physics Education.